Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Ray Optics and Optical Instruments. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it has been told that a thin plano-convex lens acts as a concave mirror of focal length 0.2 meter when silvered from its plane surface. So we have a plano-convex lens that is silvered on its plane surface, and it is acting like a concave mirror of focal length 0.2 meter. So this is equivalent to this. Okay. The refractive index of the material of the prism mu, that is 1.5, then the radius of curvature of the convex surface of the lens will be. So here, so it means that if a parallel beam of light rays are incident on it, so then first there will be refraction. So now it means that um, suppose its radius of curvature is r, so then the focal length of the focal length of the lens that will be equal to uh, mu relative mu minus 1 into 1 by r1 minus 1 by r2, which is 1 by infinity. Okay. That's why for plane surface radius is infinity. So that will be 1.5 minus 1 by r. So it is 1 by 2r. It means that the focal length will be 2r. So it means that it will converge at 2r. So therefore, it means the virtual image, the virtual object will form real image here. So it will be so the mirror will reflect. So therefore, the image of the mirror will be at 2r in front of the mirror, in front of the lens, will form at a distance of 2r in front of the lens. So therefore, it means that 2r is equal to the equivalent focal length, 0.2 meter. So it means the radius of curvature of the lens will be 0.1 meter. It means that option 3 is the correct answer. Then it is told that the refractive index of a particular material is 1.67 for blue light. So it is the mu p, I can say. And refractive index for yellow light, it is 1.65. And refractive index for red light, that is 1.63. Then the dispersive power of the material is. So we know that omega, which is the dispersive power, that is given as mu b minus mu r divided by mu y minus 1. So violet and blue will have approximately the same refractive indices. Therefore, 1.67 minus 1.63 divided by 1.65 minus 1. So this will be 0.04 by 0.65. So this is approximately, so this is 4 by 65, which is approximately, so you can say this will be 4 ones are 4, 4, approximately you can tell it is 4 6 are 24, 1 by 16 approximately, which is approximately 0.0625. So 0615. So option 1 is the correct answer. Then it is asked that rainbow is formed due to the refraction, dispersion. mm, Rainbow is formed due to dispersion and total internal reflection. Dispersion and TIR. So option 2 is the correct answer. Since why in a rainbow we can say the rain drops are acting as prisms. So here we have dispersion and here inside we have total internal reflection. So then we will see the rainbow. Then it is told that a beam of parallel rays is brought to the focus by a plano-convex lens. Plano-convex lens, it is brought to the focus. A thin concave lens of same focal length is joined to the first lens. Same focal length is joined to the first lens. So then the effect of this is, so it means we know that the equivalent focal length is given as 1 by f1 plus 1 by f2. So here the focal length of the convex lens, if it is f, so it will be plus f, since the focal length of convex lens is always uh, positive, since it is a converging lens. And for diverging lens, like concave lens, the focal length will be negative. So it is minus f. Since why it is told the concave lens will have the same focal length. So it will be 1 by f minus 1 by f, which will be 0. So it means the equivalent focal length will be infinity. So the focus shift to, the effect of this is the focus shift to infinity. It means the option 3 is the correct answer. Then it is told which mirror is to be used to obtain a parallel beam of light from a small lamp. Which mirror is used to obtain a parallel beam of light from a small lamp? Yeah. So from a small lamp, it means that we can assume that it is a approximately a point object. So here, so it is a real object. So for real objects, it should form real images, so which can be formed only by concave mirrors. So if we keep this lamp at the focus, so then after reflection from the concave mirror, it will form a parallel beam of reflected light rays. It will form a parallel beam of reflected red light rays. So option 3 is the correct answer. It should be concave mirror. Then, so in the first one, you, you told, yeah, the two are. So actually, in the second, so firstly, it is happening that the image of this parallel rays are getting converged at 2r, but okay, the second case, we have to find out v, which is the focal focus. So 1 by v minus 1 by u. U is u is 2r. That is equal to 1 by 2r. 1 by v will be equal to 1 by 2r plus 1 by 2r. That is 1 by r. So the final focal length is the radius of curvature. So this will not. So the focal length of the lens is 1 by 2r, but the overall focal length will be um, minus r only. So r will be 0.2 meter. So option here, it is not option 3, option 2 will be the correct answer. Then here, which of the following is the wrong statement? D equals to 1 by f, where f is the focal length and d is called the refractive power of a lens. Here it is true statement. So here f is the focal length which should be used in meters. And then the d equals to 1 by f is called the refractive power of a lens, and whose unit is diopters. Unit is diopters, or we can say per meter. So the power of a lens is called, the power is called a diopter when f is in meters, and power is called diopter, and does not depend on the system of unit used to measure f. And d is positive for convergent lens and negative for divergent lens. So 1, 2, and 4 statements are correct, but the third statement is the wrong statement. So option 3 is the correct answer. Here it is told that identify the wrong description of the above figures. One part A represents farsightedness. 2B is the correction of short-sightedness. 3, 2B. Okay, so uh, the first one shows that the rays coming from a far away object is converging before the lens. It means that it is called myopia or short-sightedness. It is. So it is not far-sightedness. Far-sightedness, it means that the eye which can see the far objects clearly and which cannot see the close objects clearly. So it is a myopic eye. So it represents short-sightedness. And B is the correction of short-sightedness only. Yeah, since why in short-sightedness we need a concave lens or a diverging lens. And then and then C is the represents farsightedness only. And then D is the correction of farsightedness. Since why in farsightedness we should use a farsightedness, or which is called hypermetropia. So there we need a convex lens or a converging lens. So option A is the wrong description. So it is the correct answer. Then it is told at Kavalur in India, the astronomers using a telescope whose objective had a diameter of 1 meter started using a telescope of diameter 2.54 meters. This resulted in, we know that uh, if the diameter of the telescope is d, so then the resolving power of the telescope is given as d by 1.22 lambda, where lambda is the wavelength of the light which is used, and d is the diameter of the objective. D is the diameter of the objective lens in the telescope. So here, therefore, we see that the resolving power is directly proportional to d if the lambda remains the same. The lambda remains same. So here it is told the diameter has been increased from 1 meter to 2.54 meters. So it means the resolving power will also increase by 2.54 times if the lambda remains same. So this results in the increase in the resolving power by 2.54 times for the same lambda. So option 1 is the correct answer. Then it is told to a thin prism P1, P1 which has angle A1 which is 4 degrees and made from a glass of refractive index mu1 which is 1.54 is combined with another thin prism P2 made from glass of refractive index mu2 which is 1.72, and let's suppose the angle of the second prism is A2, which we have to find here since it is told. Okay, so it is made from a glass of refractive index of 1.72 to produce dispersion without deviation. So it should produce dispersion without any deviation. Without deviation. So then the angle of the prism 2 is how much? It means A2 only we have to find. So now, therefore, for dispersion without deviation, we should have the net deviation should be 0. The net deviation should be equal to 0, means the thin prism P2 is inverted with respect to P1 to produce no deviation. So therefore, it means we should tell the deviation which is obtained from P1, okay, or I can say delta 1, that should be equal to the deviation obtained from the prism P2, which is delta 2. So therefore, delta 1 will be mu1 minus 1 into A1. That should be equal to mu2 minus 1 into A2. Okay. So therefore, we can say mu1, okay, mu1 is 1.54, 1.54 minus 1 into A1. A1 is 4 degree. That will be equal to mu2, which is 1.72 minus 1. 1.72 minus 1 into A2. We have to find out now A2. Therefore, A2 will be equal to 4 degree into 0.54 divided by 0.72. So therefore, it will be 4 degree into 54 by 72. So we can say it is 6 nines are 54, 6 1 6 6 0 12, 12 6 are 72, 3 6 are 9, 3 4 are 12, so which is equal to 3 degrees. So option 3 is the correct answer. Then it is told a fish under water, weaving obliquely a fisherman standing on the bank of a lake. The man looks. The answer will be option 1, which is taller than what he actually is. Since why? Suppose light goes from a denser to a rarer medium, so then it will bend away from denser to rarer. If it goes, then it will bend away from the normal. And if it goes from rarer to denser, then it will bend towards the normal. It will bend towards the normal. So here, and the depth apparent depth is equal to the real depth divided by mu relative. Mu relative, it means the refractive index of the, yeah, refractive index of the surrounding medium with respect to the medium of the source of the light. So refractive index of this surrounding with respect to the refractive index of the source of the light. It means that the fisherman is outside. It means we can say the apparent height. The apparent height will be equal to the actual height, the the actual height divided by mu relative. It means the refractive index of air with respect to the water in the pond. No, here we have to really use. Okay. Here actually the mu relative is the relative refractive index of the medium of the source of light with respect to the medium of the surrounding. It means here light rays are coming from the man to the fish. So here the source is the air. Source of the medium of the source is the air. And it is going, the rays are going from air to water. So refractive index of air with respect to water, that is obviously equal to refractive index of air by refractive index of water, and that will be obviously less than 1. So therefore, you can say the actual height that is less than the apparent height. Since why? Or it means the apparent height is actually more than the actual height. Since why? This part is less than 1. So it means apparently the fish will feel that the fisherman is taller than he actually is. So option 1 is the correct answer. Then for a given lens, the magnification was found to be twice as large when the object was, for a given lens, the magnification given lens, magnification M was found to be twice as large when the object was 0.15 meter distance from it as when the distance was 0.2 meter, the focal length of the lenses. So here, since as you can see all the options are positive, so it will be obviously a convex lens or converging lens. The magnification was found to be twice as large when the so here we know that magnification obtained from a lens that is given as V by U. If the focal length is F, then we can say 1 by V, that is minus 1 by U, that is equal to 1 by F. So therefore 1 by V, we can say this is equal to 1 by F plus 1 by U, and U equals to minus X. Since why for real objects, the X coordinate of the object is always negative. So it will be minus XF X minus F. Therefore, V is equal to X F by X minus F, and therefore M will be equal to V by minus X. That will be F by F minus X. So therefore, here it is told that when the focal length is 0.15 meter, so F by F minus 0.15, that is equal to twice of F by F minus 0.2. Since why here the magnification which is obtained in the first case is twice of the magnification in the second case. Therefore, we have to find out X. We have to find out F actually, the focal length of the lens. So F and F will cancel out. Then we can say that F minus 0.2, that will be equal to 2F minus 0.3. So therefore 2F minus F. That means 2F minus F, which is F, that will be equal to 0.3 minus 0.2. That will be equal to 0.1. 0.1 meter is the focal length of the lens. So option 3 is the correct answer. Then it is told white light is incident on one of the refracting surfaces of a prism. So one prism we have one prism you are having, and then the refracting angle is A of the prism. White light is incident and the angle of the prism is 5 degree. If the refractive indices for red is 1.641 and refractive index for blue color that is 1.659 respectively, then the angular separation in between these two colors when they emerge out is the angular separation delta, that will be equal to the angle of deviation for blue minus the angle of deviation for red. So it is the red color, this is the blue color, suppose. And here white light is incidental. So it will be delta B minus it will be delta B minus delta R, which is the angle of deviation for blue minus angle of deviation for red. So it will be mu R minus 1 into A minus of mu B minus 1 into A minus mu R minus 1 into A. So if you simplify it, then we will get mu B minus mu R into A. So that will be refractive index. This is that is 1.641. Sorry, yeah, 1.659 minus 1.641 into A. A is 5 degree. So therefore, it will be equal to 0.018 into 5 degree. So that will be equal to 50 to the 40. So this will be 0.09 degrees. So option 2 is the correct answer. Then it is told a transparent cube. There is a transparent cube of edge length 0.21 meter edge contains a small air bubble. So here one small air bubble is there inside it. Its apparent distance when viewed from one face is 0.1 meter. This is 0.1 meter is the apparent depth, and from here the apparent depth is 0.04. The actual distance of the bub- bubble from the second face of the cube. It means this is actual distance will be how much? So let's say it is x. And here, so it will be 0.21 minus x. So x is the actual distance of the bubble from the second face of the cube. Now, therefore, we know that real depth, and suppose the cube is having refractive index mu, outside there is air only. So d real. So we know that apparent depth that is equal to the real depth or the actual depth by mu relative, where mu relative is the refractive index of the source of the light or the medium where the source has been kept with respect to the surrounding medium, respect to the surrounding medium. So here outside is air and inside the refractive index is mu. So mu relative is mu only here. Here. So here from the second face of the cube, the apparent depth is 0.04 and the real depth is x divided by mu. And also from the first phase, the apparent depth is 0.1 meter and the real depth is 0.21 minus x meter divided by mu. Therefore, this you have to find out the actual distance, means x you have to find. So from here we can see that if we divide these two, therefore we will get for 0.1 by 0.04, that will be equal to 0.21 minus x by x. So mu and mu will get cancelled. This will be, this I can write also 10 by 4. This 2 to the 4, 2 5 is 10. So 5x equals to 0.42 minus 2x to the 4 2 on the 2. Okay. So this will be 7x equals to 0.42. So x will be equal to 7 6 of 42. So 0.06 meter. So option 1 is the correct answer. It means the actual distance of the air bubble from the second face of the cube is 0.06 meter. Then it is told the working of which of the following is similar to a slide projector. So the transmission electron microscope is similar, its working is similar to a slide projector. It will be transmission electron microscope. So in short form, it is also called TEM. Okay. It is acting as a slide projector. Since why here one slide is kept and on it some sample is placed and the particles inside that sample is then pro- projected on a screen. So it is acting like a slide projector. So option 3 is the correct answer. The twinkling effect of starlight is due to the fluctuating apparent position of the star being slightly different from the actual position of the star. Since why the twinkling effect of starlight happens due to the changing refractive index of the atmosphere. Since in the atmosphere, the refractive index mu is not constant, it is constantly fluc- fluctuating. It is constantly fluctuating. So, due to this fluctuating refractive index of the atmosphere, the apparent position of the star will also change. So, due to this fluctuating apparent position of s- the star, we we observe it as a twinkling effect. So option 4 is the correct answer. Then it is told a ray of light is traveling from glass to air. A ray of light is traveling from glass to air. One second. A ray of light is traveling from glass to air. Means that it will here is going from denser medium to rarer medium. Since here refractive index is 4 by 3 and here refractive index, no, from glass means 3 by 2 means 1.5 to refractive index of air that is 1. So here angle of refraction will be more than the angle of incidence, obviously. So if the here it is told angle of incidence is 50 degree, then the deviation of the ray is. Now the deviation will be equal to r minus I, since this angle will be I. Since vertical opposite angles are equal, so the angle of deviation of the ray will be r minus I. So here we can say that mu into sine I, that is equal to 1 into sine r. So therefore mu, that is 1.5 into sine 50, that is equal to sine r. Therefore r will be equal to sine inverse of sine 50 traveling from glass to air. It will be sine r will be equal to, so uh, sine 50 degree into 1.5 it will be. So it will be sine inverse of 1.5 into sine 50 degree minus 50 degree. And if it is and if it is going from air to glass, it is going from air to glass, then the angle of deviation will be, it is going from air to glass, suppose. So then angle of deviation will be I minus r. I minus r it will be. So then we will say that if it is from air to glass, so then angle of deviation, so this is I, this is r. So then r will be less than I if it goes from air to glass. And here if the angle of incidence is 50 degrees, so then angle of deviation will be equal to I minus r. So then we will say it is 50 minus r. And r, for r we have to say it is like this, 3 by 2 into sine r, that will be equal 3 by 2 or 1.5 sine r, that is equal to sine 50 degree. So then sine r will be equal to sine 50 divided by 1.5. So then r will be equal to sine inverse of sine 50 by 1.5. So then it will come 50 minus sine inverse of sine 50 by 1.5. So it means that if it is going from air to glass, then the angle of deviation will be 50 minus sine inverse sine 50 by 1.5. Then option 2 will be the correct answer. But here, but here it is told that the ray of light is traveling from glass to air. So here angle R is more than angle I. So then we will say that if you apply the Snell's law, so then 1.5 into sine 50 degree, that is equal to sine R. So then R will be sine inverse of sine 50 into 1.5. So then it will be sine inverse of 1.5 sine 50 minus 50. So it means that none of the options are correct. So it means no option is correct. Then here it is told that a vessel of height 2d, vessel is of height 2d, that is filled with a liquid of refractive index root 2. It's filled with a liquid of refractive index root 2 and the other half with a liquid of refractive index n. The given liquids are immiscible. Then the apparent depth of the inner surface of the bottom of the vessel will be, neglecting the thickness of the bottom of the vessel. So here the apparent depth, that will be equal to the apparent depth due to the first liquid plus the apparent depth due to the second liquid. So it will be d apparent 1 plus d apparent 2. So that will be equal to d apparent 1, that will be equal to the real depth, which is, so here the width of this liquid is also d, width of this liquid is also d. So it will be d by mu 1 plus d by mu 2. So that will be d by mu 1, that is root 2 plus d by n. So if you take d as common, then it will be, and we take LCM, that will be n root 2 into n plus root 2. So option 3 is the correct answer. Then it is told a ray of light is incident normally on one face of a right angled isosceles prism. Right angled isosceles prism, it means each angle, these are 45 degrees, 45 degrees, and this is the right angle. So then a ray of light is incident normally here. So it will pass through the prism. And then it is told it grazes the hypotenuse. It will graze the hypotenuse. So then here it means that the angle of refraction is 90 degree here. The angle of incidence, so this is 45 degree, this will be also 45 degree, this will be also 45 degree. Angle of incidence is 45 degree. So therefore here this 45 degree is acting as the critical angle for this prism. Uh, This is the critical angle for this prism. So IC is 45 degree. Now if we apply Snell's law, then we can find out the refractive index of this of the material of the prism. Let's say it is mu. So outside there is air. So we can say that here outside is air only. So here we can say mu into sine IC, that is equal to 1 into sine 45, sine 90. Sine 90 is 1 obviously. So mu into sine 45 degree, that is equal to 1. So therefore mu will be equal to 1 by sine 45 degree, which is 1 by root 2. So it is root 2. So mu will be approximately 1.414. So refractive index of the material of the prism is 1.414. Option 3 is the correct answer. Then here it is told two thin equiconvex lenses, each of focal length are or 0.2 meter are placed coaxially. It means their axis is the is common. Their axis is common with their optic centers 0.5 meter apart. The focal length of the combination is. So we know that the equivalent focal length of two lenses, if their focal lengths are f1 and f2 and their optic centers are kept at a separation of d, then the f equivalent 1 by f equivalent is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. So then, so here also the focal length is 0.2 meter plus 1 by 0.2 meter minus d is 0.5 by 0.2 into 0.2. So it's much 0.2 meter. So this will be 2 by 10. So this is 5 plus 5 minus 5 by 2. So 2.5 by 2.2. So this is 2. So it will be 25 by 2. So this will be 5 plus 5, that is 10. 10 minus 12.5. Okay, 12.5. So it is minus 2.5 meter inverse. So therefore, the equivalent focal length, that will be equal to 1 by minus 2.5. That will be equal to, so in meters it will come. So then it will be minus, this will be 10 minus 10 by 25. So 5 to the 10, 5 is the 25. This will be minus 0.4 meters. Minus 0.4 meters. So option 4 is the correct answer. Then here it is told a prism of a certain angle deviates the a prism of a certain angle deviates the red and blue rays by 8 degree and 12 degrees respectively. Another prism of the same angle. One prism of the same angle deviates the blue rays. Red is 8 degree angle of deviation for blue. Here it is 12 degrees, and here the angle of the prism is A. So it is told the prisms are small angled and made of different materials. So here the refractive index is mu1, and here the refractive index. So it means the refractive index for the yellow color will be the same for both. So here also the prism is having angle A, and the refractive index for the yellow color is the same, and the angle of deviation for red is told 10 degree, angle of deviation for blue, that is told 14 degrees. Now the dispersive powers of the materials of the prisms are in the ratio. So here is omega 1. Suppose the dispersive power of the first prism is suppose omega 1, So that will be equal to mm, so that is, as we know, delta r minus means delta b minus delta r by delta y, means the angle of deviation for the yellow color. Angle of deviation for yellow color will be the same for both of them. Angle of deviation for the yellow color will be same for both of them, since it is this mu y minus 1 into a. It will be same. Divides, okay. Another prism of same angle divides the red and blue rays by this. So therefore, angle of deviation for red we tell that is mu r minus 1 into a. And delta b I can tell mu b minus 1 into a. So this is equal to 8 degree, this is 12 degree. So therefore, if we take the ratio, then we will say that mu b minus 1 by mu r minus 1, that is equal to 12 by 8. So which is 4 to the 8, 4 3 is 12. Now therefore, we can say that mu b minus 1 I can take, let's say that is equal to into index, okay, that is equal to 3. So mu b minus 1, let's say that is equal to 3 mu suppose. So mu b that will be equal to 3 mu plus 1. Similarly, mu r minus 1 that is equal to 2 mu suppose. So mu r I can say that is equal to 2 mu plus 1. And now here delta r dash, that is different materials. Okay, so this will be mu b minus 1 into a, mu b dash, you can say mu b dash by, it is delta b dash, that is equal to, okay, mu b minus 1 into a, mu b dash minus 1 into a dash, that is delta b dash, that is equal to uh, okay, delta b dash, that is equal to 14 degree, and mu r dash minus 1 into a, that is equal to delta r dash, that is equal to 10 degree. So therefore, if we take the ratio, then we will get also mu b dash minus 1 by mu r dash minus 1, that is equal to 14 by 10, that is 2 5 the 10 2 7 the 14. So similarly, we can tell that mu b dash equal to 7 mu plus 1, and mu r dash that is equal to 5 mu plus 1. So now therefore, omega 2, that is the dispersive power, Now we have to find omega 1 by omega 2, means the dispersive power of the first prism by the dispersive power of the second prism, which is equal to delta b dash minus delta r dash by delta y dash minus 1. That will be equal to, so delta y dash is approximately, so the middle angle of deviation in the middle angle of deviation will be delta y here, that is 12 degrees, and here also delta y, that will be 10 degrees. Delta y will be 10 degrees. So actually like this also we can find, like this also it can be found with, without doing all these things. Simply we can find out delta y, which is the middle color. Yellow is the middle color with respect to red and blue. So therefore omega 1 by omega 2 we can solve it like this, that is delta b minus delta r divided by delta y minus 1 divided by delta b dash minus delta r dash by delta y dash minus 1. So this will be 12 minus 18, 12 degree minus 18 minus 8 degree by 10 degree minus 1 divided by delta y will be 10 degree, okay. Divided by this will be 14 degree minus 10 degree divided by 12 degree minus 1. So this will be equal to 4 by 9 into 11 by 4. So 4 will cancel. So it is 11 by 9. So it will be 11 is to 9. So option 1 is the correct answer. Yeah, so here it has been told that an equiconvex lens, equiconvex means on both the sides the radius of curvature is the same. So it has refractive index of 3 by 2. It is made up of glass only. It has focal length f in the air, and if it is completely immersed in water of refractive index 4 by 3, then the percentage change in the focal length is. So we know that, so we have to use the lens maker's formula. Lens maker's formula, it is given as 1 by f equal to refractive index of length by refractive index of surrounding minus 1 into 1 by r1 minus 1 by r2. Now here, since the two radius of curvature is same, so r1 equal to r2, so here, and r2 is negative, so r1 is minus of r2, let's say that is equal to r, so therefore 1 by f, that is equal to refractive index of length, that is 3 by 2, And when it is in air, so refractive index of air, we know that is equal to 1 approximately. So 3 by 2 minus 1 into 2 by r. So therefore it will be 1 by 2 into 2 by r, so it is equal to 1 by r. When it is placed in water, so then refractive index, the focal length in water, 1 by fw I get r. That is equal to refractive index of lens by refractive index of water minus 1 into 2 by r. So that will be equal to 9 by 8 minus 1 into 2 by r. So that will be equal to 1 by 8. So it is 2 fourths are 8. So 1 by 4r. So therefore, the focal length in water equals to 4 times of the focal length in air. So therefore, you have to find the percentage change in focal length. Percentage change, that is equal to delta f by f into 100%. So change in focal length, that is equal to 4f minus f by f into 100. So that will be 3f by f. So it is 300%. 300% is the increase. 300% increase in the focal length. So option B is the correct answer. Then it is told that a point object is moving with the speed the point object is moving with a speed of 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. Then the speed of the image is also 1 meter per second if when the object is at dash centimeter from the optical center of the lens. So therefore du by dt is 1 meter per second, which is constant. Du by dt means the speed of the object. So we know that 1 by v minus 1 by u equals to 1 by f for the lens. Now, if we differentiate with respect to time, then we will get minus 1 by v square dv by dt minus of minus 1 by u square du by dt, that is equal to 0. So therefore, we can say that dv by dt into 1 by v square, that is equal to 1 by u square du by dt. So therefore, dv by dt, that is equal to v square by u square into du by dt. Now v by u is the magnification, the linear magnification. So I can say m square du by dt. So dv by dt is the speed of the image. So therefore, now we know that so we have to find the object distance u. I have to find at which dv by dt is also 1 meter per second. So if dv by dt is also 1, it means that is also equal to du by dt. So therefore, we can say m should be equal to m square should be equal to 1, means m should be equal to plus or minus 1. Okay. Now, so we know that if it is real image, it will be inverted. So m will be minus 1. And if it is a virtual image, then m will be plus 1. So your focal length is 10. So if the object is at distance of x centimeter from the optical center, then we'll say u is equal to minus x centimeter. So therefore, I will tell 1 by v plus 1 by x, that is equal to 1 by f, that is 10 centimeter. So then 1 by v will be equal to 1 by 10 minus 1 by x. So that will be equal to 10x, x minus 10. So v by u, that is equal to m, that will be equal to 10x by x minus 10, this is v, divided by u, that is minus x. So this will be, 6 will cancel, so this will be 10 by 10 minus x. So now, therefore, 10 by 10 minus x, that should be equal to minus 1. So then 10 minus, so x minus 10, that should be equal to 10. So x should be equal to 20. And if m is plus 1, then it means that 10 should be equal to 10 minus x. And then x should be equal to 0, which can't happen. So it means x should be equal to 20 centimeter. So the object should be at a distance of 20 centimeter from the optical center of the lens. So option A is the correct answer. Then here it is told that for a point object, which of the following always produces virtual image in air? So we know that convex mirror will always produce virtual image of an object, and which will be virtual and it will be diminished, and biconvex lens will always so it can form real image also or virtual image also. Concave mirror also, it can form um, virtual image also and real image also. And plano convex lens also can form real and virtual image. Okay. So convex mirror will always form virtual image of real object. So option A is the correct answer. Then here it is told for a given pair of transparent media, the critical angle for which color is maximum. So we know that for critical angle, if the angle of incidence is I, and if the angle R, if the refraction angle of refraction is 90 degree, when it goes from a denser medium to a rarer m- m- medium, let's say air. So then I will say that this angle of incidence I will be called as the critical angle for this given pair of optical m- m- media. For this given pair of optical media, the critical angle will be IC if the angle of refraction at the rarer medium is 90 degree when the ray goes from denser to rarer medium. So therefore, if we apply Snell's law, then we will get mu if the refractive index of the denser medium is mu, and suppose the rarer medium is air. So the refractive index of air, we know that is approximately 1. So mu into sine IC, that will be equal to 1 into sine 90. So then sine IC, that will be equal to 1 by mu. Now, according to the Cauchy's equation, according to Cauchy's equation, we can say mu lambda is equals to a plus b by lambda square. It means that where a and b are called as Cauchy's constant. So mu of lambda, it means the refractive index that corresponds to the given wavelength lambda in a given medium. So it means that the refractive index for a given wavelength, it is inversely proportional to lambda square. So we know that to red, from violet to red, um, the wavelength of red is maximum, and wavelength of violet is minimum. So therefore, the refractive index for red is the minimum, and the refractive index for violet is maximum. And so sine IC is inversely proportional to 1 by mu. So if the refractive index is higher, so it means if the refractive index is higher, then the critical angle will be lesser. So it means the critical angle will be higher for lesser refractive index. So it means the refractive index of red is minimum. So the critical angle for red is maximum, and the critical angle for violet is minimum. Okay, so it means that for red, the critical angle will be maximum. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCT exam. Still any doubts if you have, then please write that in the comments section. Uh, we shall obviously clarify those in the subsequent videos. And in any other chapter, if you have difficulty, then please write the name of that chapter also. And please install our Sapience education application, where we shall upload some important questions based on the previous year KCET exam, which shall be obviously helpful for you. So thank you everyone. Bye.